Yes, thank you, Anka. Um, and yeah, welcome to the second talk of today's event. This talk is going to be about the LocalStack Chaos API. My name is Viren Nadkarni. I'm a software engineer at LocalStack. I'm the service owner for EC2, DynamoDB, SES, IoT, among other services. And I've also had the opportunity to work on some critical design in LocalStack framework, such as namespacing, and of course, the Chaos API, which we're going to talk about today. Right. So, as you probably know, as engineers, we want to make the cloud is all about redundancy and fault tolerance. And as engineers, our goal is to make the cloud uh, very reliable and improve its availability. But because we live in the real world and things go wrong, there's nothing that can guarantee 100% uptime. So there are ways to get around this. We generally tend to design the architecture in such a way that allows individual components of the system to fail without bringing down the entire thing. There are techniques for this, which include graceful degradation. You can implement redundancy at various levels, perhaps rack levels or data center levels or even region levels if you're worried about natural disasters and so on. But that's just the design, and designing is not enough. We need to make sure that the design works, and we need to keep testing it, just to make sure that we take care of events. When these events actually happen, things work as expected. Now, back in 2011, Netflix was moving their infrastructure from on-prem to the AWS cloud, and they realized that they need to do this exact same thing. So they built this tool called the Chaos Monkey. The name was based on the idea of unleashing a monkey with a weapon, and perhaps the monkey could shoot down servers or pull off cables, chew them off, and just cause destruction. Um, and we've come a long way since 2011, and this discipline has matured quite a bit. Today, majority of tech products make chaos engineering a fundamental part of the development lifecycle. And at LocalStack, we want to make it possible for you to integrate chaos engineering in your workflows. As you probably know, with LocalStack, you can emulate a variety of AWS services, and you can deploy your code and make sure that the tests are done properly. So in 2000, in this year, July of this year, we introduced the Chaos API with version 3.6. And the idea with the Chaos API that we have implemented is twofold. So the first part is its ability to create faults within the API. You can configure the Chaos API in such a way that faults can be triggered in any service for any operation or any region of AWS that you're using. For example, you could perhaps want to make the S3 put object fail 50% of the time in an indeterministic manner with this specific error, 403x69. So we've tried to make it powerful enough that you can control the error type and, of course, the error probability if you wish to introduce a degree of uncertainty. The second area that the Chaos API focuses on is the ability to inject network latency into API calls. The goal here is to let you test the network resilience of your design. Perhaps you want to make sure that the retry mechanisms work properly. An example of this could be to cause SQS to respond with a delay of 1,000 milliseconds or 1 second. Now, in order to use Chaos API, you need to be on LocalStack 3.6 and above, because that's when we introduced this feature. You need to be on a supported tier. We have Chaos API available on the enterprise tier, but you could also reach out to our support team and ask them to create a custom plan for you. And the Chaos API uses a JSON-based configuration, which we will look at in a moment. So The full documentation for the Chaos API is available at this URL in case you want to check it out later. Now, jumping on to the actual configuration. The Chaos API consists of, the configuration consists of a list of rules. In each rule, you can set various fields. There are fields for region, service, operation. As I mentioned, there's probability. You could also configure the error that you want LocalStack to raise. And these rules are evaluated sequentially. As soon as there is a match for the incoming request, the fault is created. I will demo you how it works in a moment. The configuration is to be deployed at this endpoint. There's the usual HTTP methods. HTTP get retrieves the current configuration, post adds a new configuration, and patch and delete are used to manipulate individual rules. Right, so let's just take a look at some example configurations. In 2021, December, AWS experienced a massive outage in the US East 1 region. You could simulate this with Chaos API and LocalStack by having a configuration like this. You simply specify the region as US East 1, and you post it to this endpoint. And that would instantly create the outage for this entire region. Yet another example is this case I mentioned earlier. If you want to make S3 put object fail half the time with this error, you specify the service as S3, operation as put object, specify the probability, and specify the error, the HTTP status code that you want LocalStack to raise, and the error message that you need to be returned. With that cleared, here's what we will try out today. We will take a brief look at a very simple microservice architecture, which consists of API gateway, some lambdas, and a DynamoDB table. Then we will try to inject faults. Specifically, we will try to bring down the DynamoDB instance, and then study how the system behaves and see whether the architecture is resilient enough. And if required, we will tweak the architecture and we'll see how we can improve the resiliency of the system. The source code for this entire exercise is available at this URL. You can try it out later. Right, so this is the diagram for the system that we'll be working with. We have an API gateway which defines two endpoints for get and post. Each of the endpoints are hooked onto a lambda. There's a lambda to retrieve a product. The product is just an abstraction that we're working with today. And there's a post. There's a post call which is hooked onto another lambda to add a product. And both of these lambdas try to access the DynamoDB database, the product DB. So let's just jump onto the demo. I have a LocalStack instance running here in another session. Let's try to make a call to the API gateway endpoint to create this one product. So this product is simply called gadget. There are some fields that we are setting, some price field, a description field, and we're going to execute this. So the product is now created. The API gateway call has been routed through the lambda. Lambda has created the entry in the product database. We can verify this by just scanning the DynamoDB table. This is the call to scan the DynamoDB table, and we can see the entry that we just added. The name of the product is gadget. Okay, so let's create the outage that we want to do. Here is the configuration for the Chaos API. We want the service to be DynamoDB. The outage should have 100% probability. And we want to raise this custom error called 500 data center not found. So I will issue this HTTP call now. And with this, the database is down. It can no longer be accessible. If we try to scan the DynamoDB table now, we will get the error that we mentioned. We get a data center not found error, and the API call fails. So the API call failed for us. It will also fail for the lambdas that are trying to access the DynamoDB table, which means that you can no longer retrieve a product or create a new product. Now, a possible solution for this could consist of creating, let's say, an SNS topic, which is hooked onto an SQS queue. And we could add a third lambda, which inspects the queue. If there's a product, it picks it up and injects and tries to put it into the database. And it could keep trying until the database until the product is successfully entered into the database. Now, this is not the most optimal solution. There's probably better ways to get around this. But I want to emphasize the goal here is to see how you can leverage the Chaos API to identify these flaws in your architecture. So we already have deployed this fallback mechanism. And keep in mind, the outage is still going on. If we try to create a second product now, I'm trying to create a product called widget. We get this message that the DynamoDB cannot be accessible, and instead the product has been queued, and the third lambda that we just saw would keep retrying to enter the product. To verify again, we can rerun the DynamoDB scan operation. We're still getting the error. But now let's try to end the outage. So in order to end the outage, we issue the delete call to the Chaos API, and we specify that we want to delete this rule that we added earlier. I will make the HTTP call, and now the the outage has ended, and the lambda will be triggered, and at some point this product that we added, the widget product, should be retrievable from the DynamoDB database. And yes, it is retrievable. We can see that now there are two entries, the gadget, that one we added before the outage, and the widget that we added during the outage. So I hope you get an idea of how you can use this mechanism to make your architecture more resilient. The second part of the Chaos API is its ability to create network effects. And the configuration for this is pretty straightforward. You just have a JSON object, which is one field, latency, where you specify the latency in milliseconds. The endpoint is this, and it's HTTP GET to get the current configuration and POST request to add a new configuration. Let's briefly take a look at how this works. So the AWS STS get caller identity call is used to retrieve information about the person, the account which is making the call. And you can see that I get a response instantly. In this case, it's some example placeholder credentials. Let's try injecting a latency here. So in order to inject a latency of 5 seconds, this is how the configuration looks like. I will make the HTTP call. And if I try to run the STS get caller identity call this time, it will make me wait at least 5 seconds. It with the time command here so that I can accurately measure how long it's taking me. And yes, it's taking me 5-point-something seconds. So this specific feature, like I mentioned before, you can use it to test how resilient your retry mechanisms are. Perhaps you want to see how the throttling strategy works, and yeah, sort out your network resilience with the system. Yes, and if you are a heavy user of the LocalStack dashboard, I'm happy to say that the Chaos API is nicely integrated with the LocalStack dashboard. it is available at this URL, and it offers several templates and experiments that you can use to play around with the Chaos API. Now, to wrap up, let's take a very brief look at some of the other tools in the market. There is the fault injection service. This is an official AWS service. This service takes a more procedural approach. So you have to define the initial conditions, the running conditions for the experiment, and the end conditions for the experiment. I'm happy to say that LocalStack also supports FIS. And depending on your workflows, it can be less flexible because it supports fewer services and fewer resource types. There is also the Chaos Monkey framework that I mentioned in the beginning. It also has a sister tool called the Simianami. It was developed by Netflix, and it also has integration with AWS. But you need some work to get it integrated with your workflows. With that, thank you very much for tuning in today. I am open for questions.